Okay, we are now on the balancing equations worksheet. We're going to do the second half, questions 6 through 10. And just like the last one, we're going to set up by just simply writing out all the elements we have first. So we have K. Notice that NO3 is on this side. We have NO3 on this side as well. Because we have it on both sides, I'm going to keep them together. That's a polyatomic ion. Then we have hydrogen. And if you look at carbonate, CO3, same thing's happening here. So I'm going to keep CO3 together. That's going to make my life a lot easier. If I wanted to, I could split them up. However, it's going to be a lot easier and a lot faster if we don't. So, going through it, we have potassium. We have 1 over here. We actually have 2 on this side. Nitrates, we have 1 here. And we have 1 here, so that's balanced. Hydrogens, we have 2 on this side. And only 1 on this side. And carbonates, we have 1 and 1. So let's start off from the top and work our way down. So, top, potassium is 2 on this side. It's only 1 on this side, so we're going to multiply the whole thing by 2. Which means that the potassium's 2, but also that nitrate there is also 2 now. So now we have 2 nitrates on this side and only 1 on this side. So we're going to multiply that side by 2. That makes that 2 now, but it also changes that hydrogen to 2. Which is a good thing because now that's balanced. And carbonate is balanced. So there's your answer for that one. Remember, there are invisible ones here that you're not seeing. Alright, so the next one, scroll on down. Maybe. Okay. We have boron, bromine, hydrogen, and just like the previous one, the NO3, we're going to keep together. So, with boron, we have 2 on this side, and we have 1 over here. That 3 only goes to what's inside the parentheses, so we're not going to multiply the boron by 3, just the NO3 by 3. Bromine, we have 6 over here. We only have 1 on this side. Hydrogen, we have 1 on the left and 1 on the right. And nitrate, we have 1 on the left and we have 3 on the right. Alright, so we have, let's start from the top. We have boron, 2 on this side, 1 on this side, so we're going to multiply this whole thing by 2 on the right hand side. That means this nitrate gets changed too. Since we kept the nitrates together as a whole, and that's being multiplied by 3, we actually have 6 nitrates now. If we look at the bromines, we have 6 bromines over here, and only 1 over here. So we're going to multiply that by 6 in order to make that 6. That changed our hydrogens. We now have 6 hydrogens as well. If we look over here for the hydrogens now, we have 6 on this side because we had to balance out the bromines. On this side we only have 1, so we're going to multiply that by 6 in order for that to balance. And that makes us having 6 nitrates now. And that's all balanced now. Alright, so number 8, we have boron, fluorine, lithium, and this is sulfite, not sulfate, sulfite. And you notice that we have 1 on the left and we have 3 on the right. But you notice that they actually stay as a group. So, boron, we have 1 here. We have 2 on the right. Fluorine, we have 3 on the left and 1 on the right. Lithium, we have 2 and 1. And sulfites, we have 1 and 3. So, moving right along, we're going to start from the top. Boron, we have 2 on this side, so we're going to multiply this by 2 in order to have 2 borons, but that also messed up our fluorine, so we now have 6 fluorines. On the right hand side, we have 6 on the left, we have 1 on the right, so we're going to multiply that by 6 in order to have 6 fluorines. That also messed up our lithium in the process. We now have 6 lithiums as well. Now, in order to make this side over here for lithium 6, you have to multiply it by 3, because 2 times 3 is 6. Now, in the process, we now have 3 sulfites on that side, which we also had 3 on the right-hand side, so that works out nicely. Okay. Ammonium is the only positive polyatomic ion that we're going to have. So keep that in mind. Most of them are usually start with metals. This one's actually starting with a non-metal. And NH4 is actually going to stay the group, because you notice it's here and it's here. We have 3 of them on the left. We only have 1 of them on the right. PO4s, we're going to do the same thing, because we see them here and on the right. So we have 4 of them on the right and 1 of them on the left. We have lead. We have 1 here, and we have 3 on the right. And then nitrates, we're going to stay as a whole, as a group. We have 4 of them on the left, and we only have 1 of them on the right. Okay, starting with the ammonium, with the NH4. 3 on the left. We're going to multiply this one by 3. So that way that makes that 3. But that also changed the nitrate in the process. We now have 3 nitrates. This could get to be a tricky one. Alright, PO4, 1 on the left, 4 on the right. So we're going to multiply this one by 4. Uh-oh, that messed up our ammonium in the process. That actually changed our ammonium to 12. Which means that we need to fix this too. So we need to actually end up multiplying this by 12 instead of just 3. And then we have nitrates now, which we now have 12 of. Alright, so the leads, we have 3 on this side. We're going to want to multiply this side by 3. And if you look, that actually changes the nitrates up here, because it's going to be 3 times 4, which is 12. So that actually worked itself out. It's nice when that happens. So the answer is 4, 3, 1, 12. And then the very last one, we have Se, Cl, and O. We have 1 Sc and 1 Se. Cls, we have 6 on the left, and we have 2 on the right. And oxygens, we have 2 on the left and 2 on the right. The seleniums are balanced. Chlorines, however, we have 6 on the left and 2 on the right. If we multiply this by 3, that'll balance itself out. And then the oxygens are already balanced. So all you had to do is add that 1, 3. So the answer is 1, 1, 1, 3. And that is the end of the first balancing equations worksheet. And if you need more help, go to the other worksheets.